Hello, my name is Holger Höpke and I'm from siliconline. Today I'm going to tell you about the latest developments of siliconline, developments which we have used to set up this optical link, an optical link capable to transport high-resolution video data at a very low power consumption. Let me briefly introduce you to the setup we have here. Here we have a small laptop which provides the video content over a DVI interface and feeds it then into this first demonstration board. On this board you see basically two chips. The first chip converts the incoming DVI signals into a 24-bit wide RGB signal plus the synchronization signal like horizontal synchronization and vertical synchronization, data enable and pixel clock. Then the second chip on this board, second IC on this board, is the first chip of siliconline. This is the SL83000. The SL83000 is used as a serializer, or is in this configuration used as serializer. It has basically two tasks. Besides the serialization of the parallel input signals into a serial output data stream, it also provides the DC balancing, the framing and DC balancing for the signal, making it thereby suitable for optical transport. You see here the SL83000 in a VQFN package, VQFN48 package, which has 7 mm by 7 mm outer dimensions. The same device is also available in a micro BGA package, which has 3 mm side length, so 3 mm by 3 mm. It's a very teeny package with 42 bolts, micro bolts underneath. From the SL83000, the signal is then fed over this differential line into a VCSEL driver, siliconline's VCSEL driver, the SL82026, which is to our knowledge the VCSEL driver with the lowest power consumption in the world right now. The VCSEL driver is connected to a low threshold VCSEL, which provides the optical output signal to this glass multimode fiber, and over this multimode fiber, which has approximately 3 meter length, the signal reaches the receiver side. On the receiver side we have again a small board, which is the optical receiver, consisting of a PIN diode and siliconline's SL82016, a transimpedance amplifier with integrated limiting amplifier. From there the signal reaches again the fourth demonstration board, again the SL83000, which is used as a deserializer in this configuration. The SL83000 deframes or deserializes the signal, the incoming signal, deframes the incoming signal and gives its output on a 24-bit wide RGB interface. From there we go one more time into a conversion chip, which is not from siliconline. It just converts the RGB signals back to a DVI data stream, which is then fed to this LCD screen. So this is basically the setup what we have. The interesting feature of the setup is the power consumption, the total power consumption. We have that now demonstrated here with these meters, with these 4 current meters you can see here. Each current meter is connected to one of siliconline's chips. The first current meter shows you the current drawn from a 1.2 volt power supply of the serializer. So you have here a current of 4.24 milliamp drawn from 1.2 volt, which is roughly 5 milliwatt. The second in the signal chain, the VCSEL driver, consumes approximately 1.95 milliamp with the VCSEL together. So the 1.95 milliamp you see here is the total power consumption of the combination VCSEL driver and VCSEL. This is drawn from a 2.5 volt supply. So again, we have here something in the order of 5 milliwatt. The next in the signal chain is the transimpedance amplifier with its differential load represented by the decalizer input. And this device draws from a 1.2 volt supply 3.8 milliamp, approximately 4.6 milliwatts. And the last silicon line device in the chain, the SL83000 in the decalizer configuration, draws from a 1.2 volt supply 2.85 milliamp. So what we have not shown here is the current drawn by the photodiode from a 2.5 volt supply. The transimpedance amplifier has two supplies, 1.2 volt supply, which supplies the entire core of the transimpedance amplifier, and the 2.5 volt supply, which is responsible for the biasing, the pre-biasing or reverse biasing of the photodiode. So with this coupling ratio what we have here, we draw approximately from this 2.5 volt another 100 microamps, which needs to be put on top of this entire power consumption. The entire link runs approximately at 50 megahertz, a little bit more than 50 megahertz, showing you a video which runs currently in an HD 720p resolution. So, bringing all the power consumptions together, we have basically here a link running at 50 and something megahertz with less than 20 milliwatts, approximately 18 milliwatts. Going to show you a little bit how the link behaves when we switch off the power. We're switching off now here the VCSEL driver power only, making the link dead. So now the video starts again. And now we're switching off. You see the monitor turns black, and if I switch on the VCSEL driver, then after a short synchronization phase, which is mainly due to the conversion chip which we have here in the chain, the video is shown again on the LCD screen. So the entire chipset is intended for application in the portable electronic market, as for example mobile phones, laptop computers, or also audio-video players, portable audio-video players. It is intended to replace electrical links which congest such hinges, as you can see here in this laptop, or specifically in mobile phones. If you have any question, please email us under info@silicon-line.com or just visit our homepage www.silicon-line.com. Thank you for your attention and have a great day. Bye bye.